So we'll start with the new topic that is known as a stack. So today's objective is to define stack, to study the stack operations that is known as an push and pop, and to study the application of stack where the examples like infix to postfix, postfix to infix, and prefix to postfix, these are known as an expression conversion where the application of stack is there. So basically stack is nothing but it is related to the memory related operations. So stack is a linear data structure which follows the last in first out data structure where the data can be stored from one side only, which is known as a top. So the top variable as shown in the figure. So whenever the new data is to be added, it should be added from the top variable. So it should be added on the top side only. If you want to remove or delete the element, it should be also removed from the top only. So that's why the stack is known as a last in first out data structure, linear data structure. So basically there are two basic functions that is known as an push and pop. Push is nothing but whenever you are going to insert the data into the stack, that operation is known as an push. So whenever you are going to remove the data from the stack, it is known as an pop. But while doing push operation, we have to check the full condition, means we are going to implement the stack using an array. So the array should be predefined. So it should be defined before the compilation. So if the size of a stack is 5, you cannot insert more than 5 elements into the stack here. So while doing a push operation, always we have to check a condition that is known as an full. So determine if the stack is full or not here. Similarly, whenever we are going to remove the data from the stack, so we have to check the empty condition. If there are no data into the stack, we have to check it that, otherwise an error will occur. So while doing push operation, we have to check the condition full. While doing pop, we have to check the condition empty. So these are the basic two operations that is known as an stack operation. So one more is there to display the elements. So how many elements are there into the stack, we have to see that. So that is known as a display function. So as shown in the example in the PPT, we will see one by one the push operation. Now to insert the 7 and 10 onto the stack, so first we have to insert the 7, means initially the top value is going to be considered as an -1, means it will point towards nothing. So it will be inserted into the 7. So the top will be pointing towards the 7. After that we are going to insert the 10. So top will be incremented by 1 and it will point towards the 10 number. So this is known as an push operation. Pop operation, it is the reverse of an push operation. So while doing pop, we have to check the condition that is known as an empty condition. If there are no elements, you cannot delete the element from the stack here. Same way, the top is pointing towards the first element of the stack that is known as an 10 number. So whenever you are going to pop the element, the 10 will come out from the stack here. So it will top will be decremented by 1 and it will point towards the 7 here. And one more element if you want to delete, we have to check the condition again empty. Whenever you are going to delete the element 7, it will point towards the -1. Top will be always pointing towards the -1. Now the applications of an stack here, that is the parenthesis matching, compilers, operating system, function call mechanism, implementation of recursion, and path finding. So these are the main applications of an stack where it is related to the memory related operations. Thank you.